This will be for the midterm review, and these are miscellaneous problems for chapters 1 through 7. Number 1, they want to know what is the maximum or minimum functional value for this function right here. All right, so I'm going to recopy this. F of x equals negative x minus 5 squared plus 12. Now I can see this function is in vertex form. Okay, so vertex form is basically y equals a times x minus h squared plus k. Now there's no coefficient here, so we can assume it is just negative 1. All right, so the value of a is negative 1. If a is negative, that means the parabola opens down. All right, if it's positive, it opens up, but if a is negative, it opens down, and that vertex point is going to be a maximum. All right, and we know that the coordinates for the vertex are h comma k. Now we're looking for the maximum or minimum. All right, so that's basically how high or low the point is, the actual value. Okay, so that's going to be the y coordinate. So we can see h is positive 5, but we don't need that. We basically need the k, the y coordinate. So k equals 12. All right, that's your y coordinate of the vertex. And we said it is a maximum since the parabola opens down. So that is answer A. The maximum value is 12. Do you need to do all this work? No, you don't. You should be able to look at an equation like this and identify it's in vertex form and say, oh yeah, the min-max is 12, and since it's negative, it's going to be a max. All right, number 2, find an equation of the line containing the points 1, 9 halves, and negative 2, 6. So the answers are in y equals mx plus b form. Whether you use y equals mx plus b or the other equation, you definitely need the slope. All right. I like to use point slope form, which is y minus y1 equals m times x minus x1. Okay, but either way, you need the slope m. So let's find the slope m first. All right, and we know that's basically change in y over change in x. All right, you have to subtract the y's and the x's going in the same order. So I like to use arrows on the points themselves. All right, so for this here, subtracting in the same order for the y's is the second coordinate. I'm going to do 6 minus 9 halves. And subtracting the x's, same direction, negative 2 minus 1. All right, and for fractions, you need a common denominator. How many halves is 6? Well, 6 is the same as 12 halves. All right, so 12 halves minus 9 halves. Well, 12 minus 9 is 3. And you still have the denominator of 2. And then negative 2 minus 1 is going to give us negative 3. All right, so we need to use keep, change, flip. You can make the negative 3 over 1 if you like, but you keep 3 halves, you change division to multiplication, and you flip negative 3 over 1. That's going to be negative 1 over 3. All right, so 3 times, well, we can cancel 3 over 3. That cancels, and that's just 1. 1 times negative 1 is negative 1. and this would be a 1 here. 2 times 1 is 2. So that is the slope m. Alright, so the slope m gets plugged in right here. And you also need to plug in 1 point. You can plug in either one, and that goes into the y1 and x1. Since you can plug in either point, I don't want to use the one with a fraction. So the first number is your x1 and the second number is your y1. Alright, so we have y minus, and y1 is positive 6. That equals the slope m, negative 1/2, times, parentheses, x minus x1, which is negative 2. Alright, so I plugged in the y1 and I plugged in the x1. Alright, the two negatives in a row make it positive, and we need to get the answers in y equals form. So solving for y, we have y minus 6. The opposite is plus 6. You want to do that to both sides. And it cancels here. Bring down the y. Bring down the equal sign. And distribute. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times 2. Well, let's see. Half of 2 is just 1, but it's a negative. So that's going to be negative 1. And then plus 6. Okay, and of course, negative 1 plus 6 is positive 5. So that's your answer right there. Negative 1/2 x plus 5. And that is answer C. Alright, if you want to use y equals mx plus b, you still need to find the slope. You plug it in right there. And again, you take one of the points, and instead of x1, y1, it's just going to be x and y. Alright, so you plug in the point at x and y, you solve for b, and you rewrite the equation. Alright, the reason I like point slope is because you can just plug it in and distribute, and you end up solving for b. So either way, you should get the same answer. Alright, number 10, f of x equals 1 minus x squared, and g of x equals 2x plus 5. What is f of g of x? I always like to rewrite this without the circle. Okay, write it with the parentheses. F of g of x. Alright, so f of g of x, what does that mean? Well, you take the f function and you're going to plug in g of x in place of x in the f function. That's all it means. Okay, so we're going to take g of x, take that whole thing, and plug it into the f function. Alright, so this right here is g of x. We're going to take that whole expression, and for the f of x function, we're going to take that and plug it in right in place of x. So we have 1 minus, use parentheses whenever you plug it in, and that whole thing is x squared. This whole thing gets squared. 2x plus 5 squared. Alright, now the answers are not in that form, so we're going to have to unpack this. Alright, so this is 2x plus 5 squared. That's basically 2x plus 5 times 2x plus 5. Okay, because this was squared, so it's multiplied by itself. And we need to distribute. Alright, we have 1 minus, and use parentheses. We're going to unpack this here. First is going to be 2x times 2x. That's going to be 4x squared. Inner is going to be 5 times 2x. That's 10x. outer is going to be 2x times 5. That's also 10x. And last is 5 times 5. That's 25. Okay? You don't have to use FOIL. You can just distribute it. It doesn't matter. And we have 1 minus distributing the negative sign. That's going to be negative 4x squared. Okay, 10x plus 10x is 20x. And if we distribute the negative sign to the 20x, that's going to be negative 20x. And the negative sign times 25, that's going to be negative 25. Okay, and cleaning it up, we can only combine the 1 and the negative 25. So 1 minus 25, that's going to be negative 24. All right, so that's your answer. Negative 4x squared minus 20x minus 24. And that is answer C. All right, number 11, that's a separate problem from number 10. All right, so they want us to evaluate f of 2 for f of x equals 7. That's actually a trick question. Okay, if you have f of x equals 7, that's the same as y equals 7. Okay, so if you were to graph y equals 7, this is the y-axis, this is the x-axis. If you were to graph y equals 7, you would just go to y equals 7. All right, so this is the y-axis. Let's say you counted 7 units up right there, and the line would be like that. Y equals 7. Okay, no matter what the x-coordinate is on this line, y is always equal to 7. Okay, if you plug in x equals 5, you get 7. You plug in negative 5, you get 7. No matter what you plug in, you're going to get 7. So f of 2, that just means you're plugging in x equals 2 and getting a y value of 7. All right, so the answer is just 7. This is the whole function right here. There's nowhere to plug in x, so it's basically saying no matter what you put in for x, you're going to get 7. So it's actually a trick question. Number 14, they give us two line equations. They want us to know if it's parallel, perpendicular, or neither. All right, if they're parallel, they have to have the same slope. If they're perpendicular, the slopes are going to be negative reciprocals. All right, so either way, we need to find slope. All right, so let's start with the first equation, 2x minus y equals 5. And we basically need to solve for y. So I'm going to do plus y on both sides. And since I have y here, I want the 5 on the other side. I'm going to do minus 5 on both sides. 5 minus 5 cancels. Y minus y cancels. Bring down your equal sign. And bring down your y. And y equals 2x minus 5. Alright, this is in the form of y equals mx plus b. I just wrote it backwards. Y equals mx plus b. So which letter represents the slope? The m. Alright, so in this line equation, m equals 2. Alright, now we have to do the other line. 4x minus 8y equals 9. Alright, we need to solve for y. The opposite of positive 4x is negative 4x. Cancels here. Alright, this is y times negative 8. The opposite of times negative 8 is divided by negative 8. And the negative 8's cancel. We have y equals. Now when you add or subtract over a common denominator, both of these terms are over the denominator. So we have negative 4x over negative 8. And we have 9 over negative 8. All right. Negative 4 divided by negative 8 is 1/2, because negative 8 divided by negative 4 is just 2. And this is 1 if you cancel the fraction. So it's basically 1/2 x. 1x over 2 is the same as 1/2 x. And plus 9 divided by negative 8 is going to be negative 9/8. All right, this is y equals mx plus b as well. We can see the slope is the number that's times x. So m equals 1/2. All right, so we might be okay. Let me see here. All right, I can see already it's going to be neither, but just for your information, you want to take the negative reciprocal of one of the slopes. All right, remember there's 2 steps. You want to flip it, which means take the reciprocal. And the second step is to change the plus minus sign. All right, so let's do this one right here because it's already a fraction. If you did this one, you just have to make it 2 over 1. All right, negative reciprocal. So 1/2. Flip it, that's going to be 2 over 1, and change the plus minus sign. Right now it's positive, so changing that, it's going to be negative. Does this match the other slope? No, it does not. So that means they are not perpendicular. All right, if you take the negative reciprocal of one slope and it matches the other slope, then they're going to be perpendicular. Okay, but in this case, that didn't happen, so they're not perpendicular. And obviously, the slopes are not the same, so they're not parallel either. Okay, if the slopes are equal before you even do the negative reciprocal, then it's parallel. So in this case, it's just going to be neither. Number 16, what is the domain for this function right here? All right, remember domain is just the possible x values. Now, if this right here were an even exponent, like if it was square root or fourth root, then underneath the radical would have to be greater than or equal to 0. Okay, but right here we have a cube root or a third root. So this could be negative. Okay, just as an example, we know the third root of 8 is just 2. All right, because if you multiply 2 3 times, you get 8. And we know the third root of negative 8 is going to be negative 2, because if you multiply that 3 times, you get negative 8. So if this is odd, you're allowed to put anything under the square root, all real numbers. Okay, but if this is even, it has to be greater than or equal to 0. All right, so basically, for x, you can plug in anything. All right, that's going to be all real numbers. All right, so basically, it's the entire number line, all the way from negative infinity to positive infinity. Nothing is excluded. All right, so that's answer D. All real numbers are allowed. Number 17, they want us to find f of g of negative 2, given this is f of x and this is g of x. All right, so as always, the little circle means of. I like to rewrite this f of g of negative 2. All right, So basically, we have to find g of negative 2. Okay, and we're going to take that g of negative 2 and plug it in for x in the f function. All right, so let's find g of negative 2 first. If we do g of negative 2, that means we just take x equals negative 2 and plug it in the g function. All right, the g function is this one right here, 3x plus 9. So we're just plugging in the negative 2 in place of x. All right, that's going to be 3 times negative 2 plus 9. 3 times negative 2 is negative 6. Plus 9, that is positive 3. All right, so g of negative 2 is 3. So f of g of negative 2 just means that's going to be f of 3. And now we're plugging in x equals 3 into the f function. All right, so plug it in wherever you see an x. So there's an x here and an x here. All right, so x squared is going to be 3 squared plus x, so it's plus 3. 3 squared is 9 plus 3, that's 12. Answer A. Number 18, what is the vertex for this equation here? All right, I can see this equation is in standard form. All right, the equation is in the form of y equals ax squared plus bx plus c. All right, so I'm going to match it up. I'll rewrite it underneath. Y equals 4x squared minus 6x plus 5. All right, so clearly we can see the value for A is positive 4, and the value for B is negative 6. Watch your plus minus signs. All right, they're asking us for the vertex. The coordinates for a vertex are h comma k, and we have a formula for the x and y coordinates. All right, for h, it's just negative b over 2a. All right, so start with a negative sign and then write your b. That's negative 6. And that's divided by 2 times a, which is 4. Okay, 2 negatives make it positive, and you can cancel before you multiply if you like. 6 divided by 2 is 3. All right, so we're just left with 3/4. Whoops. All right, we're left with 3/4. You want to take the 3/4 in order to get k and plug it in place of x. All right, because that's the x coordinate of the vertex. In order to get the y coordinate, you just plug it in. So the value of k, you want to plug in the 3/4 here and here. All right, so it's going to be 4 times 3/4 squared. And then it's minus 6 times 3/4. All right, let me fix this. All right, same equation's written right here. So that's going to be 4 times 3/4 squared minus 6 times 3/4 plus 5. All right, we have the 4, and when you square a fraction, you square the numerator and denominator. So 3 times 3 is 9. 4 times 4 is 16. And this is minus 6 is a numerator, times numerator. Negative 6 times 3 is negative 18. And that's divided by 4. Okay, negative 18 fourths. Or you can write plus negative 18 fourths. That's the same thing. And we have plus 5. All right, again, 4 times 9 is... Oh, we can reduce. All right, 16 divided by 4 is just 4. All right, so we need a common denominator. We have a 4, 4. We need to make this in terms of fourths. How many fourths is positive 5? Well, that's the same as 20 fourths. Okay, so this is 9 fourths, negative 18 fourths, and 20 fourths. 20 minus 18 is positive 2, plus 9 is positive 11. So that's going to be 11, and the common denominator is 4. All right, so the vertex, we said h comma k. And what did we get for k? We got 3 fourths because that's what we plugged in. And the k is 11 fourths. And that is answer B. All right, 30 through 35 refer to this graph in figure A14. All right, let's take a look. Is the graph in figure A14 symmetric? So they say x-axis, y-axis, origin, or no. Okay, symmetric means that it makes a mirror image. So let's test the x-axis first. All right, this is your x-axis right here. And if this were a mirror right here, you'd have the same thing on the top that you do on the bottom. Okay, we do not have that. So it's not the x-axis. Let's test the y-axis. All right, y-axis is right here. And again, you'd have this would be your mirror. You'd have the same thing on both sides. So this would also be over here if it were y-axis, but that's not true. All right, now the third one is respect to the origin. Origin symmetry. If it's origin symmetry, that means y equals x is your mirror. All right, so let's see. If we drew y equals x, that's 1, 1, 2, 2, right. For every coordinate, y equals x. Negative 1 is negative 1. So the line is basically like that. Now, just looking at this, it looks like it's true. All right, it looks like the mirror image is along the y equals x line. Okay, but if you want to check for a few points, you want to take a point, x comma y, and you see if that point matches on the other side if you change the plus minus sign on the x and the y. All right, so take any point and then change the sign and see if it's still there. For instance, this point here, it's at x equals 4 and y equals 2. All right, see if that point exists at negative 4 and negative 2. If we go to negative 4 and negative 2, we have that point right there. All right, so far so good. Let's check another one. Look at this point here. That's going to be x equals 2, y equals negative 2. So change it to negative 2, positive 2. Let's see, negative 2, positive 2. Yep, that point exists as well. All right, so it looks like it's good. If we do 1, negative 1, we have negative 1, positive 1. All right, and so on. It works for every single one of them. So this right here is origin symmetry. All right, and there's one more way to look at origin symmetry, if I can erase this mess. All right, so for origin symmetry, it's going to reflect over the x-axis and the y-axis. All right, it's going to reflect 2 times, so you can also do it that way. And the order doesn't matter. Okay, so right here, if I reflect this curve up here, it's going to be like so. All right, and then if I take this curve and reflect it over the y-axis, it's going to be right there. Okay, so basically you want to do a double reflection. The order doesn't matter, but you want to reflect it over the x-axis and the y-axis. See if you can flip it twice and match what's already there. But anyway, that proves its origin symmetry. So number 30 is C. Respect to the origin. All right, 31. What is f of -4? Well, that's easy. You want to know the y-coordinate at x equals -4. Okay, if you had a function, you'd plug in x equals -4. We don't have the equation. We just have the graph. So we're going to go to x equals -4 and find the y value. All right, this is the x-axis. Go to x equals -4 right here. Trace it to the graph. That's right there. And then trace it to the y-axis. And that's -2. All right, so this point on the graph is 4, -2. So the answer is just -2. And that is answer A. All right, y-intercept is basically where the line or graph crosses the y-axis. It's where it intercepts the y-axis. So let's see. All right, this right here is your y-axis. Okay, it intercepts right there at y equals 0. So that's it. That's your y-intercept. Answer B. All right, number 33, does the function have an inverse? You need to do the horizontal line test. All right, vertical line is to test if it's a function. Horizontal line, if it tests if it's an inverse. If it intersects more than once, then it does not have an inverse. All right, I'll write that up top, but let's go to the graph. All right, so you draw a horizontal line. If it intersects more than once, there's no inverse. All right, so if I do it right here, you can see right here, and right here, it intersects 3 times. Okay, so there's no inverse. Not for the whole function anyway. There's cases where you can restrict the x values and get it to intersect only once. But for the whole function, there's no inverse. So that is a hard no. 34, what is the range? Okay, so for the range, that's just going to be the possible y values. All right, so let's look at the graph and find the range. All right, so this is the y-axis. The maximum or highest y value is going to be +2. And the minimum or the lowest y value is going to be -2. All right, are there any holes in the graph? No, it's every possible y value between 2 and -2. All right, every decimal or fraction in between 2 and -2 is possible. All right, so on a number line, on the positive side you have a 2, on the negative side you have a -2. All right, and it's basically everything in between, including the 2 and the -2. So how would you write that? Well, you use the square brackets because it includes 2 and -2. And the lesser number is on the left and the greater number is on the right. So that right there is your range from -2 to 2. So number 34 is answer B. All right, 35, increasing intervals. What does that mean? That means it has a positive slope. All right, what does a positive slope look like? That means y and x both increase or they both decrease together, right? Positive divided by positive or negative divided by negative. So anything where the graph is like this, that is on the increasing interval. All right, so let's find where the positive slopes are. All right, so we're looking on the graph wherever it's like that. All right, so I would say this part right here from 2 to here, right here, that's definitely positive. Okay, so the interval, we're looking at the x values. All right, it starts at x equals 2 and it goes to x equals 4. So that's good right there. And where else? I would say right here. Right here to right here, that's a positive slope. So that goes from x equals -4 to x equals -2. All right, and this is negative right in here, so that's no good. We'll see. I'm not sure if they're going to have the square brackets or the rounded parentheses, but these are definitely the correct intervals. So let's check our choices. All right, and this is it right here. Apparently they don't use the square brackets in any of the answers, but we said this interval, and we also said this interval. This means in union with, so it's both of these combined. So that's the correct answer right there. This is where the positive slopes occurs, and you want the x values where there is a positive slope. All right, number 36. We're looking at even, odd, or neither. Okay, for this function right here. So what happens? Well, you definitely want to find f of -x in either case. All right, if it equals the original, that's going to be even. All right, and if you do f of -x and it equals the negative of the original, that's going to be odd. Okay, the way I remember it is that if you negate both of them, then it's going to be odd. But if you just have -x, it's going to be even. Anyhow, let's find f of -x. And that just means you're plugging in -x wherever you see an x. All right, so x squared is going to be -x squared. Make sure you use parentheses wherever you plug in -x. And that's going to be minus x, so in other words, minus -x. All right, and then on the end of the function, we have plus 2. All right, so plus 2. -x squared, well, negative times negative is positive, so that's going to be x squared. The two negatives here are also positive, so that's positive x, and we have plus 2. Okay, does that equal the original f of x? No, that does not equal the original f of x. So that means it's not even. All right. So now we have to find negative f of x to see if it's odd. All right. So we're just going to negate the entire function. It's a negative sign times the entire f of x function. So in parentheses, x squared minus x plus 2. X squared minus x plus 2. All right, this is f of x right here, and we're negating it. So distributing negative x squared. Negative times negative is positive, so negative of negative x is positive x. And negative positive 2. All right. Now, does this equal what we got for f of negative x? Oh, I can see this right here does not equal that right there. Those are not equal either, so it's not odd. All right, if it's not even and it's not odd, that means it's going to be neither. All right, 37, are these 4 points the vertices of a parallelogram? What do we know about parallelograms? Opposite sides parallel. All right, so we just want to find, and parallel lines, that means they have the same slope. So we just want to find 2 pairs of matching slopes. Okay, but you don't want to do the slopes of the diagonals. So I am going to do a rough sketch here and make sure I'm not doing the diagonals but the actual parallelogram. All right, just a rough sketch. Negative 4 comma 2. So let's see, that's about negative 4, 2 is right there. And then 1 comma 3, 1 comma 3 is right there. And then negative 1 comma 0, negative 1 on the x, 0 on the y. And negative 2 comma 5, negative 2 and positive 5. Really, I should have labeled the points A, B, C, and D. So I can do that real quick. This one is A, and this one is B, and this one is C, and this one here is D. All right, so just a rough sketch. All right, if I draw in this parallelogram, it's basically like that. Not that great, but at least we know we're not doing the diagonals. Okay, so first I'm going to do the slope for AD. All right here. The slope for AD, change in y over change in x. So I'm going to do 5 minus 2. And I'm going to do negative 2 minus negative 4. The 2 negatives make it positive. 5 minus 2 is 3. Negative 2 plus 4 is 2. All right, and then next I'm going to do dB. All right, so the slope of dB, let me erase this. dB, so that's going to be 5 minus 3 and negative 2 minus 1. All right, so 5 minus 3, negative 2 minus 1. 5 minus 3 is 2. Negative 2 minus 1 is negative 3. All right, next I'm going to do BC. All right, let's see, B to C. So I'm going to do 3 minus 0 and 1 minus negative 1. 3 minus 0, 1 minus negative 1. The two negatives are positive. 3 over 2. All right, so far so good. We have two of them that check out. And then finally, the last one is CA or AC, same thing. All right, CA. You can go either direction. 2 minus 0 and negative 4 minus negative 1. 2 minus 0, negative 4 minus negative 1. 2 minus 0 is 2. Two negatives are positive. Negative 4 plus 1 is negative 3. So that's negative 2/3. Does that match this one? Yes. All right, so we got it. Opposite sides parallel. All right, 3 halves matches 3 halves, and negative 2/3 matches negative 2/3. So do we have opposite sides parallel? Yes. So that is answer A. All right, notice the points were not in order. Okay, if I hadn't graphed this, I may have been finding the slopes of the diagonals. Okay, the diagonals don't help. So if you didn't graph it, you would have to do this 6 times, because you would have done this if you didn't get a match, because you would have done the diagonals possibly. Okay, but you need opposite sides, so you need 2 pairs to match. Number 38, the graph in figure 8A15. The solid graph is f of x, and the dash graph is the transformation. What is the transformation? Okay, let's see. What I like to do is write out the coordinates for the original. All right, let me leave some space here. All right, we have 3 points. We're going to write out the original and the new ones. So for the original, that's the solid line. Right here, this point is x equals negative 5, y equals 0. And this point right here, x equals 0, y equals 3. And this point right here, x equals 3, y equals negative 2. All right, so the original was everything for the solid line. And now we're going to do the dashed line. The new one, or the transformation, is the dashed line. So this point right here is x equals negative 6, y equals 0. And the second point, this point here is negative 1, comma 6. And the last point right here, that's 2, comma negative 4. So looking at the coordinates, what happened to each one of them? We need to find a pattern. All right. So I think we could do that. If we go from negative 5 to negative 6, that's basically minus 1. If we go from 0 to negative 1, that's minus 1. If we go from 3 to 2, that's minus 1. So it looks like the x coordinate, minus 1, it went left. So x, basically it went left 1. And for the y coordinate, it looks like nothing happened here. But if we go from 3 to 6, that's going to be times 2. And if we go from negative 2 to negative 4, that's going to be times 2. So the y coordinate is basically times 2. Now, remember, for the x, when you go left, right, it's reversed. So in order to go left 1, you have to do plus 1 on the x. But for the y times 2, that's exactly how it is. It's just times 2 on the y. So remember the original function, f of x, that equals your y, right? So the transformation, if we do plus 1 on the x, that's going to be f of x plus 1. And this whole thing right here is your new y. If you do y times 2, that just means you're going to do 2 times this whole thing. So that's your answer right there. Remember, f of x, that's your y value, but the new y is going to be f of x plus 1. And then you just do the times 2 on that whole thing. So it's 2 times f of x plus 1. And that is answer C. Alright, so you basically have to write out the coordinates and look for the pattern. Alright, find the inverse for this function here. So this negative 1, that's not an exponent. That means inverse. And in order to find the inverse, you basically have to reverse the x and the y and then solve for y. Alright, so this f of x, like we just said before, this is basically y equals. So let's write out this function, then reverse them, and then solve for the new y. Alright, we have y equals x minus 3 over x plus 4. Alright, so what you want to do is reverse the x and the y. So the y is now an x, and the x's are now y. So it's going to be y minus 3 and y plus 4. Alright, we have to isolate y somehow. Let's multiply both sides by y plus 4 to get rid of the fraction here. Alright, y plus 4's cancel. On the left, let's see, we're trying to isolate y. We can't do it as is, so we have to distribute. X times 4, that's going to be 4x. And x times positive y, that's going to be yx. Alright, I just wanted to write the x's on this in the same spot, but it doesn't matter, and that equals y minus 3. Now we need all the y's on one side by itself. So I'm going to get rid of a minus 3 by doing plus 3 on both sides. Alright, and these are together, so we're going to have to bring them over together. The y's have to be on the right. So the opposite of positive yx is negative yx. Alright, so 3 minus 3 is gone. Yx minus yx is gone. Bring down your equal sign. We have 4x plus 3 on the left. And we have y minus yx on the right. In order to isolate this y, we need to factor it. Alright, so we have y. Y divided by y is 1. Negative yx divided by y is negative x. If you want to double check, just distribute. Y times 1 is y. Y times negative x is negative yx. This side is 4x plus 3. And finally, solving for y, this is y times 1 1 minus x. The opposite is dividing by 1 minus x. Cancels here. And this right here is your y. That's your new y. In other words, that's your inverse function, f negative 1 of x. It looks like negative 1 is the exponent, but no. Again, that means inverse. So 4x plus 3 over 1 minus x. Okay, her answers are in different forms. However, if we have 4x plus 3 over 1 minus x, let's say you multiply the top and the bottom by negative, or negative 1. Alright, that's the same thing. It's like times negative 1 over negative 1. You're multiplying by 1. So if we distribute that negative, that's negative 4x minus 3. On the bottom, negative 1 times positive 1 is negative 1. Negative 1 times x is positive x. So negative 1 plus x, that's the same as x minus 1. Negative 4x minus 3 over x minus 1. That's answer C.